In this video, we're going to talk about piecewise functions. An example of a piecewise function is actually something you do frequently when you go to the grocery store. When you go to the grocery store, there are checkout lanes, and some of them say 15 items or less. And then there are others that will let you have any number of items. How do you decide which lane to go in? Okay, so what do? Well, you look in your grocery cart and you count the items, right? So first you count the items and you decide if you have maybe 1 or 2 or 3 or 4, right, all the way up to exactly 15, then you can go into that lane that says 15 items or less. If you have 16 or more items, then officially you should go into the lanes that do not have any restrictions. So a piecewise function is very similar to this. First, you're going to look at the number in your cart, so to speak, and then you're going to decide which lane to go in. Okay? So what's an example of a piecewise function? Here we have a cell phone company that offers the following data plan per phone. $50 per month, and you get 8 gigs of data. If you go over this limit, it'll cost you an additional $15 per gig. We can represent this plan mathematically by writing the total monthly cost, C, as the function of the amount of data, D. Okay, so this is going to be C of D. C represents the name of the function, which is going to represent cost. Cost of data is another way that we could say that, cost of data. Okay, so D represents the input for this function. So there's our input variable. So you can also think of it as cost is what comes out of the function, so that's the output, and data is what goes into the function, so that's the input. So we put in the amount of data and out comes the cost for the month. This function is represented by 2 equations. Okay, so this function is defined in pieces, so that's why we call it a piecewise function. So we have 2 equations that represent this function. So we have 50, so that's the top equation. The bottom equation is 50 plus 15 times parentheses d minus 8. So we can think of these as sort of the 2 lanes at the grocery store. Which of those 2 lanes do I go in? Or which of those 2 equations do I use? Well, that's going to depend on what is in your cart. Okay, so for example, we are only allowed to use the top equation if the D value, so if the input is in between 0 and 8. So it can be exactly 0 and it can be exactly 8. So this is sort of like counting the items in your cart. If you count the items in your cart and you have between 0 and 8 items, then you can go into the first lane. Okay, so the second lane is only allowed to be used if your D value is greater than 8. So only greater than 8. So we're talking about D values of 9, 10, 11, and so on. So something larger than 8. If you have more than 8 items in your cart, then you have to go into lane 2. In other words, if your D value is greater than 8, then you have to use that second equation. Okay, so let's answer some questions. How much is the monthly bill if exactly 8 gigabytes is used for the month? Okay, so what we're looking at is basically a D value of 8. So if we have 8 gigabytes of data, what is the cost? So if our D value is exactly 8, which of those 2 lanes can I go in? So this is sort of like looking into your cart. So we're going to say C of 8. If 8 goes into our cost function, so this is sort of like the number of items in your cart. First, you have to check to see how many items do you have in your cart. So what's in your cart? You have an 8. So is that D value between 0 and 8, including 0 and 8? Or is that D value that's in your cart there, is that greater than 8? Well, that's definitely in between 0 and 8, including 8. Okay, so that D value fits into lane 1. So the answer is exactly 50. That's our equation. It's just 50. So that makes sense. If you think about it as, if you use 8 gigabytes of data, then your bill is going to be that set fee of $50. How much is the monthly bill if you use less than 8 gigabytes for the month? So we're all familiar with cell phone bills. If you use 6 gigabytes, they're not going to charge you less. So which cart do we go in if our D value, let's say, is 6? Or let's say the D value is 1. It doesn't matter. We're talking about anything less than 8. So choose a number less than 8. Any of those numbers. Let's put it into our function. What is the cost of 6 gigabytes? Okay, well, we're going to look at the number in the parentheses. We're going to decide, okay, well, if this input is 6, let's think about that as the number of items in our grocery cart. Okay, what lane do we go in? Okay, well, this says if the number of items in my cart is between 0 and 8, then I go into lane 1, or we use the top equation. Well, this item is 6, right? So we have 6. Our D value is 6, and that's definitely in between 0 and 8. So we're going to use equation 1. So our bill is still $50. Okay, so that same logic would apply if we put 1 gigabyte into that function, or a D value of 1 into the function, the bill would still be $50. Okay, because the number of items in our cart is 1, and that would tell us, okay, if your number of items in your cart is between 0 and 8, then you have to go into lane 1. So if your D value is between 0 and 8, then you have to use that top equation. So your answer is just 50. So this would apply to any D value in between 0 and 8. The answer would be using that top equation, and the answer would be exactly $50 a month for that bill. Okay, so the cell phone company doesn't care if you use a little bit less, they're still going to charge you $50. Okay, so how much would your monthly bill be if you used 12 gigabytes for that month? Okay, so in this case, we're talking about the data value being 12. So we're going to put 12 inside of the parentheses to go into that function in place of D. Okay, so we need to count the items in our cart first. So look in the parentheses, we have a 12. We have to decide which of the two lanes are we allowed to go in. So our D value is 12, that is not in between 0 and 8. So we cannot use lane 1. We have to go into lane 2, where our D value is greater than 8. So we have to use that bottom equation. So we're going to put 50 plus 15 times the D value, which is 12. So we're going to put 12 in place of D in that second equation. We're going to subtract 8. So we just put a 12 in place of D everywhere we saw D in that function. Okay, now we're going to simplify. Okay, so 50 plus 15 times 12 minus 8. Okay, that's 4. 15 times 4 is 60, and that equals 110. So if you use 12 gigabytes of data for the month, you're going to pay $110 for your monthly cell phone bill. Okay, so when we have piecewise functions, we have to choose which lane are we going to go in based upon the number of items in our cart. So the input value, we look at that first. What's going inside of the function? We're going to look at that value and we're going to say, which of these two equations should I use based upon that input value? And then we're going to only use one of those equations. Okay, when you go to the grocery store, you don't go in both lanes. You only go in one lane or the other. So you don't go in the 15 items or less lane and the other one. You choose one, and that's the one you go in. The same thing with piecewise functions. You don't use both equations. You look at the items in your cart, you look at your input value, and you only choose one of those two equations to use at a time. Okay, we don't ever use both. Okay, we also have a graph of this piecewise function. We're going to look at this in a little bit, but for this particular picture, you see that between 0 and 8, okay, between 0 and 8, there is a flat graph that represents that exactly $50 bill. Okay. But then after 8, we see a change. So that makes sense because when we look back at our piecewise function, there is a change in equation at the value of 8. So when 8 is included, we use the top equation. For values that are greater than 8, where 8 is not included, we use the bottom equation. So that bottom equation actually starts to grow really quickly. Okay, and it continues to grow forever. But we see at 12, when we put in that D value of 12, we got out $110. So the value for that cost starts to change pretty rapidly once we start to go over our data limit. Okay, so you see that the graph itself actually changes after that D value of 8. Okay, we're going to look at graphing piecewise functions in a little bit, but for now I just wanted to give you an example that was somewhat relatable. You actually use piecewise functions in cell phone bills and all the time at the grocery store without even realizing it. Okay, so let's look at some more piecewise functions. Here we have f of x is equal to 2x plus 5 if x is less than 0, and then we have 2x plus 7 if x is greater than or equal to 0. So once again, we have two lanes to choose from. So the top equation, 2x plus 5, is only used if x is less than 0. So we think about the number of items in our cart, what's going in, to decide what lane we're going to go in. The second equation, the 2x plus 7, is only used if x is greater than or equal to 0. So let's look at our first question. We want to find, or what we say, evaluate the function at the given value of the independent variable. So when we put -1 into this function for x, what comes out? We have to decide which lane are we going to go in. Is -1 part of lane 1 or lane 2? So in order to decide which lane to go in, we're going to count the number of items in our cart. So we're going to think about this as the items in our cart. So first we're going to look at what's going in. -1. Is -1 going to fit in lane 1? So we only use the top equation, or we only go in lane 1 if x value, remember this is the x value that's going into the function, if the x value is less than 0. So I have to decide, is -1 less than 0? And yes, it is. Okay, if you think about your number line, you have 0, -1 is to the left. Everything to the left is less than 0, right? So I'm thinking about that number line. Okay, so x less than 0, -1 is definitely less than 0, so we're going to use lane 1. Okay, so 2x plus 5 is the equation that we're going to use. So wherever we have an x, we can put parentheses, and inside of that parentheses, we're going to place the -1. Okay, we're going to simplify that. Okay, so 2 times -1, that's -2 plus 5. -2 plus 5 is a positive 3. Okay, so f of -1 is going to be a positive 3. Okay, so let's look at the next one. We have f of 0. Okay, so first we're going to look at the 0, and we're going to decide which of those two lanes does that tell me that I have to go in. So we're thinking about that x value that's going into the function is sort of like the number of items in our cart. That's going to tell us which lane to go in. So, is 0 less than 0? Well, 0 can't be less than itself. That would mean 0 is to the left of itself, and so 0 is itself. So let's go to the next lane. In order to use lane 2, you have to have an x value that is greater than or equal to 0. So 0 is equal to itself. So we're going to use lane 2. So we're going to use equation 2 because 0 fits into that second lane restrictions. So the equation that we're going to use here is going to be 2 times x plus 7. So I'm going to put parentheses everywhere I have an x in that equation 2, and I'm going to put a 0 into those parentheses. 2 times 0 is 0. 0 plus 7 is 7. So f of 0 for this piecewise function is a positive 7. Okay, what about f of 1? Okay, so first of all, I'm going to look at the x value. Think about this as looking at the number of items in your cart to choose which lane you're going to go in. Okay, we're going to go in lane 1 or lane 2. So equation 1 or equation 2. So the x value is 1. Is 1 less than 0? Well, when I look at my number line, 1 is over here. Anything to the right of 0 then would be greater. So 1 is not less than 0, that is not true. So I cannot use lane 1. Okay, is 1 greater than or equal to 0? So that is a true statement. 1 is greater than or equal to 0. So that means for that last function value, we are going to plug that into equation 2, so that bottom equation. Okay, so we're going to use 2 times x plus 7. We're going to put a 1 into those parentheses, and we're going to simplify. 2 times 1 is 2. Bring down the 7. 2 plus 7 is 9. So if a 1 goes into this piecewise function, we get an output out of positive 9. Okay. Let's look at example B. This time we have function g. G of x is equal to, and so we have two pieces, two equations to represent the function g. We have x plus 4, but we can only use x plus 4 if the x value that we're plugging in is greater than or equal to negative 4. And the second equation is negative, and then we have parentheses, x plus 4, but we can only use that second equation if the x value that we're plugging in is less than negative 4. Okay, so if you want to, you could think about writing this as part of a number line. We'll put negative 4, since that's mentioned in both of those inequalities, we'll put negative 4 right in the middle. And remember that anything to the left of negative 4 on the number line is less than negative 4. Anything to the right of negative 4 on the number line is greater than negative 4. Okay, so we're asked to plug in, first of all, a 0. So we want g of 0. So this is the x value that we're going to plug into the function. So we have to decide what lane do we go in. Okay, which of these two does 0 fit into? Where is 0 on our number line? Okay, 0 is to the right of negative 4 on our number line. So 0 is greater than negative 4. Now if you have a hard time with negative numbers, you can ask yourself, would you rather have negative $4 in the bank or $0 in the bank? And if you said $0 in the bank would be better, then 0 must be greater than or to the right of negative 4 on the number line. Okay, so is x value that we're looking at 0, is that greater than or equal to negative 4? Yes, it is. It is greater than negative 4 because it is to the right of negative 4 on the number line. So I'm going to use that top equation. Okay, so I'm going to put parentheses plus 4. Okay, so I'm going to put parentheses everywhere I have an x in that top equation. And we're going to drop a 0 into those parentheses. 0 plus 4 is 4. So when a 0 goes in to this function g, defined in pieces, we get out a positive 4 for y. Okay, what about g of negative 6? G of negative 6. Negative 6 is the x value that's being used as input into the function. Okay, we have to decide which lane to go in. So I'm going to use the top equation or the bottom equation. Well, that's all based upon the restrictions for x before I go into that lane. So we're talking about negative 6 here. Where's negative 6 on my number line? Well, would you rather have negative $6 in the bank or negative $4 in the bank? Well, I'd rather have negative $4 in the bank. So that must mean negative 4 is greater. Okay, so things that are larger go to the right on our number line. So that must mean that negative 6 is to the left of negative 4. So anything over here to the left of negative 4 is smaller or less than negative 4. So negative 6 is over here to the left, so it is less than negative 4. Okay, so which of the lanes can I go in? The top equation can only be used if the x value that I'm plugging in is greater than or equal to negative 4. Well, negative 6 is not larger than negative 4, so I can't use that top equation. The bottom equation, equation 2, I can use this equation if the x value that I'm plugging in is less than negative 4. And it is. So for this x value, we're going to plug it into that bottom equation. So we're going to use negative parentheses plus 4, and the negative 6 that we're plugging in is going to go where the x is in that second equation. So I'm going to plug in my negative 6 right where the x is in that second equation. Okay, so let's simplify using order of operations. We're going to simplify inside of the parentheses first. Negative 6 plus 4 is negative 2. Negative negative 2 is a positive 2. So when we plug negative 6 into function g, into that piecewise function, we use the second equation, that bottom equation, and we get out a positive 2 for y. Alright, I'm going to change this, and I will correct this in your notes so you won't have to change this, but I'm going to change this to be g of negative 4 for that last example. So g of negative 4. Okay, let's say that the x value that we plug in is negative 4. Okay, if we're plugging in an x value of negative 4 into function g, which equation can I use? The top equation or the bottom equation? So the top equation is only used if the x value that we're plugging in is greater than or equal to, so remember that line underneath is or equal to, negative 4. So is negative 4 greater than or equal to negative 4? Now the or equal to part means that we are exactly at negative 4. So is negative 4 equal to itself? And the answer to that question is yes. Negative 4 is included in that top equation. Negative 4 is not included in that bottom equation restrictions. So that means we're going to use the top equation when we want to plug in that negative 4. Okay, so we're going to use x plus 4. So I'm going to put in parentheses plus 4. We're going to put the negative 4 inside of the parentheses. And then we're going to add those two numbers together. Negative 4 plus 4, that gives us 0. So g of negative 4 gives us an output value of 0. Okay, let's look at example part C. Here we have function h. So we have h of x is equal to, and then here we have a function that's defined in two pieces. So the top equation is x squared minus 36 divided by x minus 6. We can only use that top equation if x is not equal to 6. So this one is a little bit different. Okay, when you think about your number line here, we have 6 in the middle. And so that top equation can only be used if the x value that you're plugging in is not equal to 6. Okay. If the x value that you plug in is equal to 6, then the equation that you're going to use is just 2. So that's a really easy equation to use. The answer is just 2. Alright, so let's see how we do h of 3. So h of 3. 3 is the x value that's going into the function. Alright, so we got to figure out which lane are we going to go in. Okay, the number of items in our cart we can think of as exactly 3. Okay. If the number of items in our cart is not 6, then we get to go into lane 1. Okay, so if the x value is not 6, is 3 6? 3 is not equal to 6, so 3 is not 6. That means that as long as it's not 6 exactly, then I can use that top equation. So as long as my x value is not 6, then I have to use the top equation. Alright, so that means I'm going to put parentheses everywhere I see an x in that top equation. So I have parentheses squared minus 36 and then parentheses minus 6. So I'm going to put a 3 in place of x in those parentheses. Okay, so at the top I have 3 squared, that's 9, minus 36. At the bottom we have 3 minus 6, that's negative 3. 9 minus 36 is negative 27 over negative 3. Okay, negative 27 divided by negative 3, and negative divided by negative is a positive. 27 divided by 3 is a positive 9. So when we put a 3 into that function, we get out a positive 9 for the y value. Okay, what about 0? Okay, 0 is over here on my number line. Okay, so the x value that I'm plugging in is 0. Okay, the only restriction I have is to decide if the x value is 6 or not 6. This x value, 0, is not 6. So since it's not 6, then I have to use the top equation for when x is not equal to 6. Okay, so we're going to use that exact same equation that we used for positive 3. Okay, so I'm going to put parentheses everywhere I have an x in that equation. So that's parentheses squared minus 36 divided by parentheses minus 6. I'm going to drop in a 0 into all of those parentheses. Okay, let's simplify. 0 squared is 0. So at the top now I have 0 minus 36 over 0 minus 6. 0 minus 6 is just negative 6. Remember, we're going to simplify top and the bottom separately before we do anything else. So at the top I get 0 minus 36, which is a negative 36. So I've simplified the top and the bottom separately of the fractions. And now that I've simplified top and the bottom as much as I can, now I can see, is there something that I can do to simplify that fraction overall? A negative divided by negative is a positive. 36 divided by 6 is a positive 6. So when we plug a 0 in place of x in function h, we get out a positive 6. Okay, so our last example here, we have h of 6. So the x value that we're plugging in this time is 6. Okay, so what we have to decide to figure out which lane we're going to go in is the x value 6 or not 6? Well, this time the x value is exactly 6. Okay, so we're actually right on the money, right on the 6. If the x value is 6, then we have to use lane 2. And the answer is just 2. So that's a really nice, really easy equation, just equals 2. Okay, so that's all we have to do. H of 6 equals 2, and that's our final answer if x is equal to 6.